Hello and welcome to a ramble with me. I've just filmed such a horrifying video. I'm really hoping this question is going to treat me better than the last one did. Yo, my goodness. We are dealing with question 10 from paper 2 of November 2022 of the department. Hey. The department's paper 2, yes, that's what we're looking at. Right. In the diagram, PQRS is a cyclic quad. Thank you for letting us know. KP is a tangent to the circle at P. C and D are points on chords PQ and PS respectively, and CD produced meets RS produced at A. CA is parallel to QS. CA is parallel to QS. Yes. RC is drawn. RC is drawn. Fun fact. And P1 is equal to R2. Okay. Prove, giving reasons, that S1 is equal to T2. S1 is equal to T2. We don't have any centers, so boo-hoo. So S1 and T2. So I'm trying to see, okay, what's related to T2? I see that it's related to, so it's equal to C2 because of alternate angles. And then what's happening with S1? S1, so D2 will be equal to S1 plus that guy. Oh, wait, and we got parallel lines, triangles, similar triangle stuff going on. I don't know. These two are supplementary. And this is equal to this. Yeah, okay, potato. Wait, where are you trying to get to? S1 is equal to T2. Okay, who is S1 related to? Nah, NJ. Just out here being a sponge. Okay, I don't know why I'm calling it a sponge. There's really no need to call it a sponge. Because what does that even mean? Okay, so I mean this is equal to this because of tan chord. That is equal to that. No, yes, yeah, that is coming from this chord. Yo, I was going to say it's equal to this, but it's not coming. This is not coming from here. It's not coming from this chord. But anyway, I'm just going to fill that in so long. So this and this are equal, we were told. And we know that it's equal to that as well because of tan chord. There's the cyclic quad situation J as well going on somewhere in the MIGs. We don't have, okay, I was going to say we don't have any exterior angles, but we do. That is an exterior angle. So that S1 is equal to this guy, Q1 plus Q2. That might be good to know at some point, right? Is equal to those two together. And we said, I remember us talking about, we said T2 is equal to that one because of alternate angles. It's a maze meal. So we want to show that T2 is equal to S1. So T2 is also orange. So the same as showing that this is orange. Okay, so in the meantime, I mean, it's blue. That's as much as we know. Oh, wait. Okay, but this is green because of corresponding angles. Right. And then how does that help me? Oh, how does that help me? Oh, it does help me because this plus this plus this is 180, angle sum. But also this plus that same angle is 180 because angles on a straight line. So these two must be equal. Okay. So how do I say that? Okay, first of all, can I just retrace my steps? What on earth just happened? Okay, so I'm using the fact that these two are equal because of corresponding angles. Okay, but how do I know that that's green? It's green because of tan chord. So I didn't really need that one just yet. Okay, so that's the first thing. Why did I need this? Did I even need it? Oh, I did for this one. Okay, cool. So that's part one of the puzzle. And then we have this angle, which is in this triangle. Oh, I do need it for here. Right? And then that shows that this is equal to this. But how do I know that this is equal to that? I know it because cyclic quad exterior angle. Ooh! Hallelujah. Okay, let's do this. So I'm too scared to erase it because what if I forget my train of thought? So we said Q1 is equal to P1 because the tangent being KP and the chord being PS, right? That chord subtends Q1 at the circumference, so these two are equal, right? In fact, let's just deal in x's. Okay, maybe let's leave the x's for now. Right, then next up we said C1 is equal to Q1, and that is because of corresponding angles The parallel lines we're looking at are SQ and AC. Right. And then, so that was that. That gave us these relationships over here. Okay. And we also know that R2 is equal to P1. It was given. Okay. Right. So therefore C1 is equal to, to really spell it out, maybe let me move this one down. Oh, Nami. Okay, wait. Let me leave this out. Maybe this is a sign for now to just rewrite it. Okay. So by getting C1 equal to Q1, what really matters is that we show that C1 did we even need to know that P1 is involved? Oh, we do. Eventually. We don't need it yet. Yeah, okay. Let's write down what is necessary. Okay. So what is okay, I'm going to wrap this out because I must have faith. I must have faith that I'm going to remember. I must just have the faith. Okay, so we started out by saying C1. We didn't start out that way, but we are starting out that way. C1 is equal to Q1, right? Right. Then we want to say oh, I forgot my train of thought. Oh, guys, the thing I feared would happen has happened. Okay. So we want to show that this angle is the same as this angle. Oh, okay. So, okay. Oh, my poor brain. Right. So, we also know that Q1 is equal to P1 because of the tangent KP meeting with the chord PS and the chord PS subtending the angle Q1 in the alternate segment. Right? But we know that P1 and R2 are the same. So what this tells us is that Q1 is the same as R2. Q1 is equal to R2 because P1 is equal to R2, right? So we now have those are equal. And then what it eventually helps us with is it shows that therefore C1 is equal to R2 as well. So we could have gone yeah, because really what we wanted to get to is showing that C1 is the same as R2, which we could have said by saying, well, C1 is the same as P1 because C1 is equal to Q1 and Q1 is equal to that. So C1 is equal to P1, which means it's equal to R2. So, yeah. I don't know. Why did I write this? Yeah. Guys, if it's painful watching this, just imagine how much more painful it is living it. Right. So Q1 is equal to R2 because P1 is equal to R2. Therefore, C1 is equal to R2. Yeah, it's pretty much the same as what I said before because Okay, no, I'm not going to explain that to myself again, right? So we now have C1 is equal to R2. Cool. So now we can show that because this C3 is on this straight line, right? And we have C3 plus this guy plus Mr. Blue, and we know that that's 180, but C3 is also in this triangle, right? And we have Mr. Blue over there and C3, so that means this angle must be equal to that angle. So let's see if we can write that out nicely. So we know that C1 plus C2 plus C3 is equal to 180 degrees because angles on straight line, let's say PCQ, right? Then we also know that angle R2 plus angle Q plus angle C3 is equal to 180 degrees because angle sum of triangle CRQ. Okay, so since C1 is equal to R2, right? We have that there, and we have C1 and R2 showing up here, and C3 is common to both sums. Okay, that means that C2 must be equal to Q. Right, so we have shown that C2 is equal to Q, but Q is also equal to this guy because of this cyclic quad, and that exterior angle is equal to the opposite interior one. So but C2 is not C2 man but Q is equal to angle S1 because exterior angle of cyclic quad, and the cyclic quad is SRQP. Okay, so therefore angle S1 will be equal to angle, where were we even trying to go? Do we even care about C2? Oh my goodness, we're trying to show that it's equal to T2. Yo. The plot was lost. Oh, but T2 is equal to T2 because of alternate angles. Oh my goodness. Okay. Right. So that is really not the mic drop moment we wanted just yet. Okay, so far we have C2 is equal to Q, C2 is also equal to T2, so C2 is also equal to T2 because of alternate angles on the parallel lines QS and AC. Okay, so we have that, but Q is equal to S1, right? Weird comma flying in the middle of nowhere. Okay, so therefore Q, not Q, we don't care about Q. Therefore Q is equal to T2. Okay, so here we see that Q is equal to T2 because C2 is equal to both of these guys. But it's also equal to S1. So therefore, we can finally have our moment of triumph. Therefore, S1 must be equal to T2. Oh my goodness. This is just the first third of the issue at hand. And we are already being dribbled. Ganje. Let me just go over it again for my peace of mind. So C1 is equal to Q1 because of corresponding angles. Q1 is equal to P1, which I'm also going to highlight in blue, because of tan chord. And then Q1 is equal to R2 as a result, because these two are equal, right? Which means that C1 is equal to R2, because I show that C1 is equal to Q1 and Q1 is equal to this guy, then that means that these two are equal, right? And we know that C1 plus C2 plus C3 is equal to the same thing as R2 plus Q plus C3, okay? And because C3 is common to both of these, that means these are equal. And we know that C1 is equal to R2, so that means that these two must be equal. Okay, right, that's where the comma was meant to be. Okay, so now we've shown that C2 is equal to Q, but C2 is also equal to T2 because of alternate angles, right? And Q is equal to that guy because of exterior angle of a cyclic quad. So because these two are equal, then that means these two must be equal as well. Oh. Hey. Right, next question. Show that AD over AR is equal to AS over AC. Okay, so I mean, AD over AR is equal to AS over AC. It was smelling like similar triangles, but there's a switcheroo here, because it would be similar triangles if they were saying AS over AR is equal to AD over AC. So a bit of a no to that. However, that being said, I do see potential for similar triangles over here. We have that little system of ours going on. So from this system, we can see that, but why do we care? This is going to give us AS and maybe something about AC, but there's no AD, and there is an AR. Ooh. Okay, so I'm just going to quickly jot down RS over AR is equal to RT over RC is equal to ST over AC. Okay, so let's see how many of the sides we're interested in show up here. We have AC. AS we could find in here somewhere. And then there's AR. So the denominators look great. So if we can show that AD and AS have some sort of relationship with RS and ST, that would be great. RS, AD, and then RT and AS. RS, AD, RT, and AS. Okay, let's also just fill in what we know from previous question. Okay, repositioning in case there isn't enough blood flow into my head. Okay, so sorry, just erasing things. My fingerprint smudges on my screen. Okay. So we want to show, so if we do cross multiplying things, AD times AC is equal to AS times AR. Yeah, I hope it is abundantly clear that I am stumped. Yo. Yeah, what is happening in this world? Right, I don't know what I would need to show this, short of a miracle. AD. I'm also just trying to think if there's any merit to, what's going on here. So if I have A over X is equal to B over Y, and then somewhere in some other world I have c over the same x is equal to d over y. Is there anything anything about these two things that... So let's do it with real numbers. So if we have 9 over 12 is equal to 3 over 4, okay, and then here in this world we also have an over 4 over 4. So if we have 6 over 12 is equal to 2 over 4, well, these are in the same ratio. 9 to 3 is the same as 6 to 2. That comes to 3 to 1. Let's use different numbers. So 3 over 12 is the same as 1 to 4. Okay, so there is something to it. I'm about to pummel myself mercilessly. 1 over 12 is the same as 1 over 3 over 4. A third divided by 4 is a 12th. So the answer is yes. The ratio of A to C will be the same as the ratio of B to not B to D, not B to Y, B to D. And why is that? why is that? That is the case because, so if we have the following scenario, what did I just write here? Okay, anyway, I think I wrote A to C is equal to B to D. Is that true? Is that what I just saw? So there was a 9 and a 3 and a 6 and a 2. Yes, okay, it is true. Another way, so what I actually said in the numbers was that this ratio would be the same as this ratio. Okay, so the question is, why is that true? It is true because from the first one we'll have AY is equal to BX. From the second one we'll have CY is equal to DX. And so A over B will be equal to X over Y. And over here we'll have C over D equal to X over Y. So A to B will be equal to C to D. And I guess from there it's not hard to see why that is true. So if A over B is equal to C over D, that means AD is equal to BC, and then we can have A over C is equal to B over D. So divide by C on both sides and then divide by D on both sides. Okay, so that's fun to know. So that gives me a bit of direction, right? Because by knowing that RS and ST, well, pretty much if I can show that AD and RS have a relationship that is the same as the relationship between AS and ST, the ratio between these two is the same as the ratio between these two, or the ratio between RS and ST is the same as the ratio between these two, then that can, bridge these worlds together somehow. I'm just going to quickly highlight this because I keep drawing them out and then I forget what I just drew. So AD and RS potentially have a relationship, and ST and AS potentially have a relationship. Let's see. What can I tell about their angles? So I immediately see that this is already red because of the vertically opposite angles. Next up, I'm trying to see this angle, if it's related to anything. So it comes from this chord. This chord doesn't subtend anything else to the circumference. I almost looked at this one, but this is not an angle at the circumference. This angle, what's going on for you, my brother? So it comes from this chord and this chord. Oh, this is not a chord. Oh, the tragedy of it all. So we know that these are supplementary. Okay, this angle is equal to this angle. This angle comes from this chord. Got excited. Doesn't come from the chord though. There's no other action from this chord, unfortunately. This is equal to that. This is equal to this. This angle, what's going on for you? So I see the triangle here with the red. So then I get curious about this angle over here, which I have a feeling I've asked about, but anyway. Okay, but I mean, whatever I was hoping to achieve, moving myself, no, my dreams are still valid. Okay, so if I can show that this is equal to this, we are getting somewhere. Or if I can show that this is equal to this, we are getting somewhere. You know? No, Aisha, they're making us sweat here. Making us sweat. I mean, using similar reasoning to what we did before, right? This angle is common, so it's in this triangle, and it's also on this straight line. So this angle must be equal to that angle. So these two are equal. And then that must mean that this is equal to this one, right? And that must mean that this angle is equal to this one. Ooh, guys. Rearranging myself again, because what is even happening in this world? Okay. So I'm just going to quickly clean up here. Can I move this eye? Yeah, I cannot move the eye. Okay, so I'm just going to shrink this real quick. Yo, there's another question. Oh, the agony of it all. Okay, right. So, okay, before I go very far, I just want to see if this does in fact do anything for me. So by showing that these two triangles are similar, so we now have triangle SDA is similar to triangle TRS, right? S and T, S and T, D and R, D and R, A and S, A and S. Okay, so what that does for us is it gives us SD. Maybe let's just do things in alphabetical order so that it's easier to spot similarities. So DS over RT is equal to AD over RS is equal to AS over ST. Okay, we can also write them the other way around, because I'm seeing that over here I have my RS's and ST's on top. So RT over DS is equal to RS over AD is equal to ST over AS. Okay, so now let me see what's going on here. So I've got AD, I've got AD and AS, which are also in my original statement up here. And then I've got ST and RS. Over here. Okay, so we know that RS over AD is equal to ST over AS, but also RS over AR is equal to ST over AC. So RS times AS is equal to AD times ST. Okay, we're trying to get to a point where we're showing that these are equal. So okay, so then I'll try and I'll get RS over ST is equal to AD over AS, and then I'll do a similar thing here to get RS over ST equal to something else, and then equate those two. Okay, so so there is, it can work out for me. Whew, something tells me I'm taking the most painful route possible to solve this problem, but okay. Absolutely no shame in lang dry. I was so excited to start a new paper one after this video, but I think my capacity has been reached. Okay, so first of all, we want to show that these two triangles are similar, so that's pretty standard. I don't like this color anymore. So in triangle RST and triangle RAC, okay, we have R is common. We have angle RST is equal to, oh guys, was it right underneath my nose the whole time? Oh, it was, because parallel lines, these two are equal, because of vertically opposite, therefore these are equal, oh. Okay, RST is equal to angle RAC because of corresponding angles on the parallel lines ST and AC. And then finally, what's the last angle? And I'm calling them by name when I have numbers. Oh guys, why would I do such a thing? RST is S3, and RAC we can just call A. Right, and then the last angle is angle, they don't name this angle for us, so that is RTS is equal to angle C2, because also, or just third angle. Okay, so therefore triangle RST is similar to triangle RAC because of angle. Okay, so we'll use that shortly. What we want to do as well is show that these two triangles are also similar. So we have, we've already shown that angle, okay, so wait, firstly, in triangle RST and triangle ASD, okay, we have the angle S3 is equal to the angle A. We've already proven that. We have the angle RTS is equal to angle T2 because they're vertically opposite, right? But T2 is equal to S1, which was already shown, right? In question 1. Probably why we were asked to show it in question 1, so that we can use it here. Right, and then finally, the last angle is angle R1 is equal to angle D1, and that is because third angle. Okay, right, and so therefore triangle STR is similar to triangle ASD. So S no, S and A, T and T and S, T and S, and then R and D. Okay, cool. So now I will switch on the light because my eyes are twitching. Headache is threatening. Okay, let's go. Now we can say, so the ones we really care about are the ones that have RS and RT, because that's common to both of them, RS and RT. Well, so is ST, but why we care about RS and RT is because in the first one, what are we trying to find? We're trying to find the ones that have AR, okay. AD is going to come from the second triangle. AS is also going to come from the second triangle. And AC is going to come from this one. So I'm just going to underline the ones I want. So I want AC, okay. And I want AR. Okay, so that's what I want from the first one. And then from the second one, okay, we'll get to the second one just now. Let's deal with that first. So, the first two, RS over RA is equal to ST over AC. Right, and we saw that the end goal is to get a fraction involving these two. So I'm just going to go ahead and cross multiply. I'm just going to rewrite that as AR. So then we have RS over ST is equal to AR over AC. Right, divide both sides by ST and then divide both sides by AC. Yeah, okay, so we've got that from the first one. Then from the second one, we said we want AD, so we want AD, and then we want AS. So we want AS. Okay, so we're going to take, I didn't give reasons. Angle here. Okay, so, and here we need to give the reason of the similarity. Oh my goodness. Okay, so it's because these ones, I don't know if you have to write this when you have just proven it literally the line before, but anyway, I mean, not complain. Okay, that is not sitting well with me. I'm gonna write it big first and then shrink it. Okay, right, so here we're going to say the first two, so ST over AS, and then first and last, SR over AD. That is because triangle STR is, too many lines, similar to triangle ASD. Okay, so now we do a similar thing to the other one. So that is AS times, and this one I'll just rewrite as RS. Okay, and then if we divide both sides by ST, so we want ST at the bottom, and then so that'll get the ST to the bottom here. Then I need to get rid of this one, so I need to also divide by AS. So on the one side we'll end up with AD over AS is equal to RS over ST. Okay, right. Okay, so therefore AR over AC will be equal to AD over AS. We are almost there, right? We have AR at the top, AC on the other side. Oh my goodness. Okay, so this is a mixed masala, so we need to rearrange. So cross multiply again. AR times AS is equal to AD times AC. Okay, and then what do we want this to look like now? We want AD at the top on the one side and AS at the top on the other side. So we're going to divide both sides. So here we need to get rid of the AR. And then we said we want AD at the top. So here we need to get rid of the AC. Right? So therefore, AS over AC is equal to AD over AR. Right? AS over AC is equal to AD over AR. Oh my goodness, this was completely harrowing. Like, my heart and my soul, I give you control. Wow, okay, but definitely, like, what was a breakthrough for me in this question was to look at, okay, the moment I see ratios, I don't know if this is a fair bias to have, but it immediately makes me think of similar triangles. Maybe somewhere, somehow they are involved. And, you know, looking at the sides that we were given, though, AD, AR, AS, AC, it didn't feel like we're going to have any success showing that these are similar, and in fact, oh my goodness, but they are. Oh my goodness, they are similar. This wasn't necessary at all. They are similar because common angle. These two are equal. These two are equal. Oh, Nkosi yami. Kubuhlungu. Kubuhlungu. Wow. Okay, so all we had to do was show that, okay, we know that these are equal from the previous question. This is a common angle, therefore third angle, therefore the moral of the story is, guys, don't get stuck on one pattern. Behold, the Lord is doing a new thing, man. But anyway, I'm so glad we finally arrived. She's last question. Wow. This question is actually not hard, like just in terms of how much computation you need to do. It's hard because curveballs, and you must study for your exam so that you don't forget that there are two ways to prove something is a cyclic quad, right? AC times SD is equal to AR times TC. AC times SD is equal to AR times TC. What's going on now? AC times SD is equal to AR times TC. So I mean, at this point, okay, we didn't prove this for our last question, we should have, but we know that triangle ASD is similar to triangle ACR, right? Because this angle is equal. So we have AS over AC is equal to SD over CR. So AC times SD is equal to AC times SD. What am I saying? AC times SD is equal to this is when you know that high power ihambile, right? AS times CR. Okay, then from the other triangle, because now this AR and TC, yeah, that would be nice if they had used an RT or something, because then we'd get that from the other triangle. But anyway, let's just persist. So from the other similar triangles, right, we know that ARC is similar to SRT that we've seen from the previous question. TC is related to TR because it's the same as this guy minus this guy. So I'm just going to try and get a statement that involves RT and AR. So AR over SR, and then I want RT, so that will be the last two letters, right? And we said that RT is the same as RC minus TC. Okay, so that gives us AR times RC minus TC is equal to, let me also just write these in alphabetical order so that I don't miss anything by virtue of letters being swapped around. So that is equal to the product of that RS times CR. So I've got AC times SD here, and then AR times TC. AR times TC is hidden somewhere in here. So let me just write this out. Okay, I'm going to keep with the order that they have in the question. So this is the same as AR times CR minus RS times CR, right, is equal to AR times TC. So AC times SD is equal to that, and AR times TC is equal to that. And so technically then this should be equal somehow. AR, let me just see here. So this is CR times AR minus RS. AR minus RS, which is AS, right? AR minus RS. So this is CR times AS. Oh, hectic. So then they are equal, right? Because we've got CR times AS for both of them. So this and this must be equal. Okay, so let's do it. Let's do it again. A strong feeling that I am overcomplicating it. I am even running out of saliva in my mouth. I am really just like shaking my head at this question, shaking my head in disbelief. Okay, so first things first, so what stood out for me is we are looking at, so I'm just going to highlight the sides we're concerned with. AC, SD, AR, and TC. Okay, so what stands out to me about these sides is, okay, this one is inside this system of similar triangles. This one is in both, the ones I'm concerned with, both this one and this one. I just looked at the same triangle. This system and this system. This one is in the weird one and this one is in the weird one. Right? So it makes me feel like if I can use it, this is a crossover between this system of similar triangles and this system of similar triangles. So I'm first going to prove that this triangle is similar to this one, so that we can have some kind of relationship between this side and this side. This we've already proved are similar, so I'm just going to show find a relationship between this side and this side. Okay, so let's do first things first. In triangle SAD and triangle CAR, okay, A is common. Angle S1 is equal to angle C2. Well, we know that it's equal to angle T2, right? We proved that in the beginning. And angle T2 is equal to angle C2, which we also showed in the beginning, but also it's because alternate angles. Right. And then finally, the final angle D1 is equal to angle R1 because third angle. So therefore, triangle ASD is similar to triangle ACR because of angle, 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 right? And then what we wanted from this system of similar triangles is something about this line, not this one is this one. Okay, so we wanted something about this line and something about this line. These other two we'll deal with from that other system of similar triangles. So we want something about AC and something about TC. So we said we don't have, not TC, ST, sorry. Yo, wrong color. So we said last two over first two. Oh man, last two, and then on the other side we have first two. Okay, because of this similarity relationship. Okay, right, and I am now going to get this product so that we have the left hand side. Okay, so we have AC times SD is equal to CR times AS. Okay, so now we park that. Then we look at the other system of similar triangles, right? So we know from previously we showed that triangle RST is similar to triangle RAC. Okay, so here we want something about TC, but we won't get something about TC directly because we want, we either want a side that's in here or a side that forms this triangle. So the closest we're going to get is RT. Okay, and then something about this side, AR. Okay, so we're going to say first and last, and then the first two. Okay, so that is going to be, so I'll write that as RT times AR is equal to CR times RS. Okay, so how close are we to what we want? We've got the AR, okay, but then we've got TR here instead of TC. Okay, we've got the TR instead of the TC. So I'm just going to rewrite this TR so that it's in terms of TC instead, right? So I can do that by saying CR minus TC, right? That's the same as RT times AR is equal to CR times RS. Okay, then by chance I just so happen to multiply this out, because what do we have to lose? Why did I write this as TC? Oh, because the question has it as TC. Okay. Right, so now I've got the TC times AR that the question has, so I'm going to isolate it. CR times AR minus CR times RS, and then move my AR times TC term to the other side. AR times TC, as the question has it. But then we notice that, well, this is the same as saying CR times AR minus RS. But then we look at the picture, and if you have AR and you take away the RS bit, then you're just left with AS. So this is the same as CR times AS. Right, which is what we got here as well. So that means that these two must be equal. Oh, I am so ready for the memo to show me all the little things that I skipped that could have made my life so much easier approaching this question. But wow, what a workout for the brain cells. Starting with, where is the memo even? Okay, so for the first one, why do I feel like, okay, so none of these questions are like, show that there's no values here, it's just proving. So by virtue of arriving at the correct result, I am going to assume that, you know, I made sense. Okay, so I'm just going to look at what the memo did. So for the first question, which was to show that S1 is equal to T2, they first say P1 is equal to Q1 because of tan chord. Perfect. Then they say S1 is equal to Q1 plus Q2 because exterior angle. Okay. Right. So that means that S1 is equal to P1 plus Q2. Right, because S1 is the same as Q1 plus Q2, that means that S1 is the same as P1 plus Q2 because these two are equal. Okie dokie, I'm good with that. Then we're told T2 is equal to T2 is equal to R2 plus Q2. Oh, okay, because exterior angle of triangle. Okay, so T2 is equal to R2 plus Q2. Okay, because exterior angle of triangle. Okay. But P1 is equal to R2. Okay, so T2 is the same as P1 plus Q2 because these are equal. So that means that S1 and T2 are equal. Ah, that's very cool. Oh, what a workout. That's very cool. That's very cool. I worked out many intermediary angles, but yeah, this is cool. This is cool. So just to go over it again without assistance from the memo, these two are equal. This is equal to that. So S1 is the same as this plus Q2. T2 is the same as these two added together, but this is also the same as P1. So T2 is also the same as P1 plus this guy. Okay, nice. Well, that's a very nice and clean proof. Right. Then the next one, I mean, I'm glad to see it's 5 marks. Okay, but yes, it was just that aha moment that I had a bit too late. It was just showing that these two triangles are similar, and then the ratios came from there. So yeah, no further questions, Your Honor, for that one. Then this last one, hey, what was happening there? So for the last one, they start by saying AS over AC is equal to SD over CR because of the similarity in those two triangles. So then they get an expression for AS. Then they say AS over AR is equal to CT over CR. AS over AR is equal to CT over CR. Fair. Because I mean, the fact that we have this parallel line here means that the ratio of this to this is the same as the ratio of this to this. So because the ratio of this to this is equal to the ratio of this to this, it also makes sense that the ratio of this to the larger side is the same. I don't know if my reasoning is making sense, but it makes sense to me that the ratio of this to the whole side is the same as the ratio of this to the whole side. So they just minus their pain nyana by using that fact. Okay, yeah, that's an interesting proof. So yeah, let me just go over it again. So first they say so pretty much the way, using the same reasoning that we did, we wanted the sides that we end up with at the end, those sides we want to end up with are AC, SD, TC, and AR. So they said AS over AD is equal to SD over CR. So that's from, right. Then from the second triangle, they say AS over AR is equal to TC over CR. And then, so yeah, so that's just saying what? AS over AR is equal to TC over CR. So then they say from the first equation, AS is the same as SD times AD over CR, and from the second one, AS is the same as TC times AR over CR. And so therefore, these two are equal because these denominators are the same, which is what we wanted to prove. AC, oh, I think I used the wrong sides. We want AC Where did I get AD? AS over this side. Oh, golly, golly. Okay. Right, so definitely a much tamer way to approach the question, but also just using that idea of which system of similar triangles is going to give me the sides that are in the statement that I need to prove. So which triangles are going to give me the SD, where am I going to get the AC, and so on and so on. So what a compelling question. I don't even have an outro. I'm just going to collapse and live and collapse.